We want to do the same thing with atoms that we did with dimes, be able to weigh them, to count them. Instead of counting 100 atoms or molecules, we're going to use a much bigger number so that the mass is something that's reasonable to deal with in the lab. We're going to use this number. It's called Avogadro's number. It's a huge number, and as you'll see, this gives us masses for this number of atoms that are reasonable. This is a definition. A mole is 6.02 times 10 to the 23rd, just as a dozen is equal to 12. So mole means this number for when you're counting things, just like a dozen means 12. You need to memorize this number, and do know that it's not exact. This has been rounded to 3 significant figures. Also, we abbreviate mole. I don't know why, but we leave off the E. That's quite common to leave off that E. Okay, so using the word, 1 mole of carbon atoms means 6.02 times 10 to the 23rd carbon atoms. Okay, so that's what we mean when we say a mole of carbon atoms. And here's the fun part. 1 mole of carbon atoms has a mass of, and that's not rounded off much at all. Where did I get that number? From the periodic table. This number is actually the atomic weight. But instead of reading it in AMU, I'm reading it in grams. So off the periodic table. Let's see where I'm getting that number from. Now this one has been rounded off. My periodic table rounds, I have them rounded off to 1 place past the decimal for most of them. But that's what we're talking about. Remember, this top number is the number of protons. This number is the atomic weight. And if we read that off in grams, it tells us the mass of 1 mole of that atom. And like our analogy for the coins and how we would need a different mass for each one, there would be a different mass for each one. A mole of iodine atoms is 126.9 grams, much larger than a carbon atom. So anyway, that's where we get those numbers. So now we can define molar mass. Molar mass means the mass of 1 mole. So when we read off these numbers off the periodic table, that is the mass in grams of 1 mole. So we could say it's grams per mole of any substance. So for example, oxygen, its formula weight or molecular weight, those two mean the same thing, is 32.0 AMU. This is the mass of 1 molecule of oxygen. Its molar mass, mass of 1 mole, is the same number, but in grams per mole. So just restating some things and making sure we're clear on what's going on here. So the mass of 6.02 times 10 to the 23rd oxygen molecules is equal to 32 grams. Let's do some practice on molar mass, and I think we can fit this one right here, so we'll just add this one right here. Let's see. Lead 4 nitrate. Let's do a molar mass. So we need to write a formula first. Lead is a metal. This is a polyatomic ion, so I'm going to write charges. Lead goes first, then nitrate. Nitrate I know is -1. What about this lead? How do I get a charge of lead? Remember that the Roman number tells us the charge, so it's +4. Then to get a good formula, I need to cross these down. Nothing reduces. Let me just clean it up. Okay, now I'm ready to calculate a molar mass. If I look on my periodic table, the atomic weight of lead plus nitrogen is 14, but how many nitrogen atoms are in this formula? This 4 multiplies through, so this is 4. How many oxygen atoms there? 3 times 4 is 12, and its atomic weight is 16. So multiply, add those all up, and the units are very important, grams per mole. So now we can do some conversion type problems because we've just learned 2 new conversion factors. This is our little map showing how we're going to get from one quantity to another. To go between grams and moles, we need a conversion factor that involves grams and moles. And our new conversion factor is molar mass. You know the units for that are grams per mole. So we can use that to get there. That's our bridge. And then we need a conversion factor that relates moles and number of particles. And that's just the definition of a mole. It's Avogadro's number. The units for Avogadro's number are number of particles, if we're counting particles anyway, per mole. And by particles, that's kind of a general term for either meaning atoms or molecules, whatever we're counting. Okay, reminder about where we get these. Molar mass, we're adding up the atomic weights. And this number, 6.02, this is called Avogadro's number. We're ready to do some practice, and I could fit one of these problems on this slide, but I'm going to do 3 of those, so I'm going to add that to the next video, and you're going to need some paper besides your PowerPoint paper. Maybe you can use the back of a sheet.